Hey everybody, this is your video for the 6-1 Math Excel on square root functions as inverses. So basically we just finished the quadratic chapter, so now we're doing the inverse of quadratic. It's the inverse of quadratic. So on the first one it says write the inverse of f of x equals 7x minus 4. So the first thing you want to do automatically is you want to change f of x to be y and then switch x and y. Now sometimes we switch x and y in the equation, sometimes we switch x and y in the table, but it's the same process, like the same thing that you want to do for getting the inverse. So to start with, we have y equals 7x minus 4, and then that turns into x equals 7y minus 4. Then we add 4 to both sides and divide by 7 to cancel this. So you have the inverse is x plus 4 over 7. Or you could separate it. Remember, if you have a compound numerator, you're able to do that as long as you don't have a compound denominator. So that would be 1/7 x plus 4/7. So basically the inverse of a linear function is a linear function. Okay. The inverse of a linear function is a linear function. So just because this looks weird, it's the same thing as if you have a slope of 1/7 and a y-intercept of 4/7. Okay, for the next one we have y equal negative x squared plus 5, so you change it to x equal negative y squared plus 5. Then what I did is I brought my y squared to this side by adding, and I subtracted x to this side to make it like this. Then you just take your plus and minus the square root of negative x plus 5. So you are going to have to do the plus and minus, because when you take the square root you have both, because the little 2 indicates there would be two answers, and so plus and minus indicates the two answers, one positive, one negative. Also, you may note that sometimes if it's a minus x or a negative something, that they like to put that in the back. So these two things are equivalent. You could have plus and minus the square root of 5 minus x. The next step to do on this is to graph it, and then notice that it reflects across y equal x. So the original one is y equal negative x squared plus 5, so you basically go up to where 5 is and then do a parabola that opens down. And then when you're graphing this, you go to where the 5 is and make it left. So like I've said, if the parabola on the original is down, the inverse is left. And in the same way, if it were up, then it'd be right. And just pay close attention to whether it had to be a positive 5 or a negative. But in this case, it did have to be positive. Okay, the next thing is says graph the relation and the inverse. So we have a linear function y equal 3x plus 3, which turns into x equal 3y plus 3. Then you just subtract 3 and divide by 3, and so there you have it. X minus 3 over 3, which is the same thing as 1/3 x minus 1. I prefer the 1/3 x minus 1 when I'm graphing, because I know I could go to negative 1 as my y-intercept and then go up 1, right 3. Up 1, right 3. And this 1 is the y-intercept, 0, negative 1. A lot of these things are review. It kind of ties into Algebra 1 and other things you did earlier this year. The next one says graph the relation in the inverse, and it's a multiple choice. So on this one, it has y equal x minus 7 squared. So that transformation would be going right 7, because if it's a minus 7, then it's right when it's inside parentheses. And then that would also tell you your x-intercept would be 7, 0. So the more you do these, the more comfortable and fast you'd be. So the original function is going to look like this, and then we want to graph the inverse. And like I said before, you could use a table. You need to switch x and y, or you could find the new function and use the table. And then again, like I said before, if the original opens up, the inverse opens right. So these are both parabolic curves. This is the original. I'm going to put OG, and then this is the inverse. I'll put IN. Okay. For the next one, it says use the definition of inverses to determine whether f and g are inverses. So we have 5x minus 30, and we have g of x is x over 5 plus 6. So these numbers are not exactly the same, but remember, we're thinking about inverse operations. And so this one had times 5, and this one has divide 5. Now, the other thing that's a little different about this is this says minus 30, but this says plus 6. That doesn't make sense, does it? Actually, it does, because if you factor out your 5, then it's going to be x minus 6. So this one has minus 6, and this one has plus 6. So that's how that's going to work. So your times or multiply by 5 becomes divide, your minus 6 becomes plus 6. So that's how you can think of it as inverse operations. Those are inverse operations. Now normally what we would do is we would do f circle g or f composite g. So you put f and then you write the g function, which is the x over 5 plus 6, and then you apply f to that function. Well, the f is 5 times x minus 30. So we have 5 times something minus 30. And you put this in for the x, and then you're going to just distribute, and if it's really an inverse, your numbers are going to cancel and you'll get x. And so then I'll just put a little check mark. So it worked for the f circle g, but now we have to do the g circle f. You have to do both sides, because there are times I've seen before, like in pre-cal and other places, sometimes Algebra 2, where one of them is x, but then the other is not. So when you do g circle f, that means you're doing g of f of x, so g of the 5x minus 30 function. So the g function is x over 5 plus 6. So we put something over 5 plus 6, and then you put the 5x minus 30 where the x was. So then from there you want to divide your 5. So this turns into x minus 6 plus 6, which is just x. And so that worked. So then, yes, they are inverses because both directions on the composite are equal to x. It is going to be really important for you to learn how to do your composite figures like we've been talking about, because you need to do this in pre-cal, and then in calculus they have f, g, and h, so 3 different functions. So you really need to get the basics down, to be prepared for that. The next one is a temperature problem. It's saying f equal 9/5 c plus 32, which you may recognize from science. You know, that's your temperature conversion. It says find the inverse, is it a function? So the first thing I would do on this is change the f to be y and the c to be x. So that's the original. This is the OG, which is the original. And then you switch x and y, and so you have x equal 9/5 y plus 32, and then you just start solving for the new y. So you subtract 32, and then either divide by parentheses 9/5 or multiply by 5/9. You want to flip it to cancel, basically. And so this becomes 5/9 x minus 32 equal y. So then when you do that, the y becomes the c in this case, and the x becomes the f. So this is your temperature equation solved for Celsius. So this would be what I call the IN, which is the inverse. So when you think of it in terms of x and y, well, that's just a linear function that's originally written, and then the inverse is also a linear function. So if it's linear, then it would be a function for the inverse. So that part's probably the same for everybody, but then you're going to have a different temperature for everybody. This one says find it when it's 28 degrees Fahrenheit. And so you basically put 28 for the f into the inverse function, subtract, and then multiply. In this case, I rounded to the 10th, which is one place. And so negative 2.2 degrees Celsius would be the same as 28 degrees Fahrenheit. Basically, 32 degrees, as you probably know, is freezing. And so if it's below 32, then it would be below 0. Below 32 degrees Fahrenheit would be below 0 Celsius. Now, if you saw something like 28 degrees Celsius, that would actually be very hot. That'd be like 100 degrees or something. I'm just estimating. But make sure you pay attention to your F and your C. Now, on the next one, it says f of x equal the square root of x minus 7. So we make that y. And again, the process is switch x and y, so this would be x equal the square root of y minus 7. So how do you get rid of the square root? Well, what you do is you square both sides. So you make this x squared, and then you make this y minus 7. So basically what we're doing is we're doing this to both sides. Square both sides. And so when you square both sides, your square root sign and your little 2 cancel out. So it's just y minus 7. Then you want to add 7, and then that's your answer. You have your inverse is x squared plus 7. Now, you also need to talk about the domain, or answer things related to the domain and range. And so on your original, you know, if you were to graph this, it would be x greater than or equal to 7, because the graph would basically be like this. And on your x squared plus 7, that would be a parabola that opens at 7, and you just want the right side there. So, as you can see, this is your f, which is your OG function, and this is your f negative 1, which is your inverse function. And so your domain is x greater than or equal to 7, and your range is basically above the x-axis, so y greater than or equal to 0. And then on this one, your domain is x greater than or equal to 0 because it's the right side of the y-axis, and then your range would be y greater than or equal to 7. So that's how you work it individually. Now also make sure you pay attention to how things are related. So the domain of this one is going to be related to the range of this one. This says x greater than or equal to 7, and this says y greater than or equal to 7. And in the same way, this says y greater than or equal to 0, and this says x greater than or equal to 0. So that's how they're going to want it. But just to re-emphasize that, the interval notation of this would be bracket 7 comma infinity. Bracket because it's greater than or equal to. It includes that number. And then if it's y greater than or equal to 0, it would be bracket 0 comma infinity. And then this x greater than or equal to 0, again, would be bracket 0 infinity, and this would be bracket 7 infinity. So here you can actually see that they match identical. So the domain of the original is the inverse, is the range of the inverse. And the range of the original is the domain of the inverse. Okay, on the next one we have f of x is 121 over x squared. So switch x and y, or switch x and f of x. So this would be x equal 121 over y squared. So you multiply by y squared to bring it over here and divide by x. Basically, they switch places. Okay, so the x goes under and the y squared goes over. And then you want to take your plus and minus the square root. And it is a tall square root, which means both. And you can separate that into plus and minus the square root of 121 over the square root of x. The reason why you would want to do this is because 121 has a perfect square. It's 11 squared. So you have plus and minus 11 over square root of x. And so that would be 11 over the square root of x, comma, negative 11 over square root of x. Then you're going to want to graph it and then determine whether it passes the vertical line test. On the next one, you have x plus 3 squared. It's a multiple choice thing about the inverse. So first thing is we change f of x to just be x and change x to be y. And then since this is squared, we want to take the square root of both sides. Basically, whatever you do to one side, you have to do to the other. And so to get rid of this little 2, you got to do the square root like that and that. And then this little square root cancels with the 2, so you have y plus 3. So now you want to subtract 3 from both sides, so you have negative 3 plus or minus the square root of x equal y. And that's the same thing as if you were to put the plus and minus square root of x in front, and then the minus 3. And then you have to, on your own, answer questions like, is the inverse a function? And you do that by graphing. See if it passes the vertical line test. Okay, and then on extra practice A, which is number 10, you have y equals 7x squared minus 9 and x equals 7y squared minus 9. So you bring your 9 over and then divide by 7. So it looks like that. So you have your x plus 9 over 7 equal y squared. So you got to take your square root of both, so it's plus and minus the square root, x plus 9 over 7. In this case, it is, the tall square root just like always, but you can't split up the square root of 7 into like 2 something or 3 something. And so that's why we're just going to leave it that way. So that's your inverse, and you want to graph to see if it's a function. And again, use the vertical line test, or VLT. Okay, on our last one, it's extra practice B. You have f of x equal negative x squared plus 11. It's multiple choice. You want to pick the correct inverse. So basically, the f of x is your y. So we have y equal negative x squared plus 11. Then you're going to want to switch x and y and solve. So we move the y squared to the right and move our y squared we move from the right to the left, and we move our x from the left to the right. And so then you have plus and minus the square root of 11 minus x. So that would be your inverse. Now you need to find the domain and range of the original function. So the original, which is this one, the OG, I put that over here, y equal negative x squared plus 11. So that would be a parabola that opens down and has a y-intercept of 11. So your domain would be all real numbers, because this keeps on getting wider and lower than 11. So y less than or equal to 11. So again, that would be like negative infinity, comma 11, bracket, because it does include the 11. Now you want to find the domain and range of the inverse, and so if you graph this one, remember you're going to have to say f1 is your positive and f2 is your negative. The square root of 11 minus x. So that means you're going to have above and below. So this domain would be x less than or equal to 11. So basically negative infinity, comma 11 bracket, just like we had for the range of this one. And then your range would be infinity, because, or basically negative infinity to infinity, it's all real numbers, because this keeps getting wider and wider. And then it asks if the inverse has a function, and it's not, because it fails the vertical line test. All right, hope that helps. That'd be the end of that video.